right? So this is the coordinate system that you will use if you want to locate any of the atoms in a cubic system. And just that body centered one, right, it is right in the middle. So you go half in X, you go half in Y, and you go half in Z. So the body centered one will be half, 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 right? Now there are points, after that there are lines, and after that there is a plane, and after that there is the whole volume, right? So this is how the geometry goes. 0 dimension is a point, 1 dimension is a line, 2 dimensions is a plane, and 3 dimensions is the full volume. So you have done points just now, coordinate systems. So now we want to find out that how can you find directions? How can you find directions in a cubic unit cell? Directions. Now this is a very simple question, right? You know your vector geometry. You have done that in your Sanaviya, you have done that in the university, you have done that many times. So once you have vectors, you are going from one point to the other point. So there is a direction. There is a direction, and that is it. And how do you find the direction? You take the coordinates of the last point and subtract from it the coordinates of the first point. So if you know the x, y, z of the first point and you know the x, y, z of the second point, then it is just a subtraction of the coordinates, and this is the direction indices. This is the vector that gives you the direction. So this is very, very simple. Therefore, direction index means direction one of them. Indices is the plural. So x, y, z direction indices, and they are based on position coordinates that we just did. So let us see, right? So here we are showing you different directions, right? This direction, this direction, this, we're showing you different. And so you see that 1, 2, 3, 4, 5. There are 5 examples on the same page. Many times students tell me do more examples, this, that. But see, for example, if we do this, only this one, then we are doing 5 examples for you. When we did coordinates one slide ago, then we did 5, 6, 7, 8 different ones. So if you understand this slide, then that is it. Direction indices are gone. So I will take one. So let us say this one. So we are doing only one direction at one time. We want to do only this one. We want to do only this one, right? So you are starting from here and you are going there. So the starting point is what? 0, 0, 0. Yes. And the ending point is what? You have moved 1 in the x direction and 0 in the other directions. So this point, what is the coordinate? 1, 0, 0. What was there? 0, 0, 0. So by the method of vector indices, that is it. You do x, y, z of this minus x, y, z of that. So 1, 0, 0 minus 0, 0, 0. So this is what you get in the end, right? So, and this is in this book and throughout the course, this is how we will represent, we will denote direction, that this will be this type of a bracket, and in the 3 numbers x, y, z, there will be no comma in between. If you remember previously when we were writing coordinates, if I was to write coordinate of this point, then I was writing parentheses, those round ones, parentheses, and 1, 0, 0. So if that is the thing, if it is those round ones which are called parentheses, and if there are commas between the x, y, z, then that 1, 0, 0 in round ones, parentheses, that is the coordinate, that is the point coordinate. But when you write it in a bracket like this, when you write it in a bracket, which are the rectangular ones, and you don't have any commas in between, then these are the direction indices for this direction. This direction is from the origin to this point, this direction with an arrow, a direction. Okay. So I just want to tell you that many times we know very basic things, but we forget about them. The round ones are the parentheses. These rectangular ones are called brackets. And if you have a wavy one, then don't call them curly brackets, call them braces. So if you are mathematically correct, the three types of brackets that you use. One is parentheses, this one rectangular one is called brackets, and the curly ones are called parentheses. So your mathematical wording is very correct. Okay, now let us go to the second direction that is shown here. We are coming from the origin to this point S, right? So the direction vector OS. So this is 0, 0, 0. What are the coordinates of this point? You go 1 in X, you go 1 in Y, and then you don't move. So the parentheses is 1, 1, 0, right? 1, 1, 0. Now for direction indices, you subtract 1, 1, 0 minus 0, 0, 0. So you get 1, 1, 0. But now this is the direction. This is the rectangular bracket and there is no comma in between, right? So it is as simple as this, that in the cubic system, if you want to find any direction, if you are starting from the origin coordinates are 0, 0, 0. Find the coordinate of the ending point of this direction, whatever direction it is. Subtract the second point minus the first point, and you have the direction indices. One more example. You are going from the origin to this point T. So you are traveling 1 in the X, 1 in the Y, 1 in the Z. So the coordinate of this one is 1, 0, 1, 1, 1. And when you subtract 1, 1, 1 minus 0, 0, 0, you get 1, 1, 1. But this is the direction, right? The rectangular bracket with no commas. If we were writing coordinates there, we will have the round ones, which are the parentheses, and 1, 1, 1. But when it is the direction, it is the bracket, the rectangular one, with no commas in between. So this is the direction index or direction indices for this one. Let us take another example. When it is not going to any corner, it is going somewhere in the middle. It is going from the origin to somewhere in the middle. But the distance is given. So you travel 1 in X and half in Y. So the coordinate of this one is 1, half, 0. So now 1, half, 0 minus 0, 0, 0. So you get 1, half, 0 in the direction indices. 1, half, 0 in the round bracket. You don't get this one. You get 1, half, 0 with rectangular brackets. But it is a tradition that in direction index we don't use fractional numbers. So the result that you originally got is 1, half, 0. But if it is a direction index, then you don't use fractional numbers. So to convert half, you multiply it to whole number by multiplying it by 2. So it was 1, half, 0. You multiply all of them by 2, you get 2, 1, 0. You get 2, 1, 0. So originally it was 1, half, 0. But you multiply it by 2, so you get 2, 1, 0. Now if you remember, in direction, in vectors, if there are vector coordinates x, y, z, you multiply it by number, the direction remains the same. It is only then the length of the vector increases. The length of the vector increases. So technically this vector is not 2, 1, 0. 2, 1, 0 will be here. 2, 1, 0 will be a longer vector, but the direction will exactly be the same, right? Direction will exactly be the same. This one correctly, to be very correct, is 1, half, 0. But because we have a tradition that in direction indices, in crystal structure, we want to remove the fractional numbers, so we call this one 2, 1, 0. So it is technically correct, the direction is the same, only that the length of the vector will be increased. We are not worried about the length of the vector here. We are just worried about the direction. Let us take one more example. Now you are starting from this point. You are not starting from the origin. You are not starting from the origin, right? So this is new. In all the previous examples, we were starting from the origin. We were going to one corner, second corner, third corner. We were going to a half point, but we were starting from the origin. So we said the final point minus the original point. But this time the final point is here. So this time make a new origin. Make a new origin, because you want final point minus original point. So if you are starting from here, make this the origin. So this is new, make this the origin. Okay. So now if you make this the origin and you go there, you see x plus is this side, this is x minus. So if this is the origin, you are not going this side, you are going in the minus x, you are going minus x. Similarly, if you go there, the plus y is here, you are going in the minus y. So if this is the origin, you go minus 1 and minus 1, and then in z you do not move. So the coordinate of this point, if this is 0 0 0, the coordinate of this point is minus 1 0. Okay. So right, so this is important, that now your origin is here. So moving x will be this direction, moving minus x will be that direction. From here, moving plus y will be here, moving minus y will be here. So therefore this point is minus 1 0. Then that minus 0 0 0, you get minus 1 0, right, as the direction, not the coordinate. The coordinate will be minus 1 comma 0 in round parentheses. This in square brackets is minus 1 0. And this is the second thing that we do in direction indices. We don't write minus 1 with the 1 here. We don't write minus 1 here. We don't write minus 1 here, because then we can confuse that is it a subtraction or not. So we put the minus sign on top of the number. We put the minus sign on top of the number. So this is minus 1, this is minus 1 as a direction index, So these are the direction indices of this vector, right? So you have learned that sometimes you need to shift the origin. When the origin shifts, some of the numbers will become minus, and after subtraction, when you get the direction index, after subtraction from the coordinates, when you get the direction index, if any number is minus, then we show minus sign above the number, not as a normal minus 1. So on the previous page, you learnt a technique that in the direction indices, if any number is a fraction, you multiply by the minimum number, so the fractions go away. And here you learn two new techniques, that sometimes you may have to move the origin, and therefore some numbers become minus. And if in the direction indices some numbers are minus, we write the minus sign up. So here we are just doing sort of a flow diagram and so on. But the important things are that if the direction is from the origin to a point, just find the coordinates of the second point, and the direction index is second point minus origin. So for all points which are starting from the origin, all direction indices, this is the thing. If the direction is from some other point, starting from some other point, then make that other point your origin, so that now some of the directions will be minus. If there is any fractional number, then make it a whole number and multiply all of them by that. If there is any minus sign, show it at top of the direction index rather than beside it, right? So this is it. So here, right, here as an example, if you are going right 1 half 1, right, it is this half point on the front face. So you are going 1 here, you are going half here, and you are going 1 there. So it is 1 half 1, but then you will multiply it by 2, and this will become 2 1 2 2 1 2. So the direction index will be the 2 1 2 and so on, right? So this is the final summary of the. Now let us do some examples of the opposite kind, right? You were doing there that if a direction is shown to you, then can you find the direction indices? Now we give you some direction indices, 1 0 0 1 1 0. You draw it yourself, right? So this is the other practice. And just like we told you earlier when we were doing FCC BCC, the first basic practice is to quickly draw a cube, and then you go from there.